Hi there. Welcome back to this tutorial series where we're building a Sokoban game in Unity. In the previous episodes, we set up the project, added a player, and implemented smooth grid-based movement for the player. In this episode, we're going to add boxes and create the mechanics to push one box at a time. So we already have the player in our scene, and now we'll create a box. Since the box shares similar properties with the player, we'll start by duplicating the player object as a base for our box. First, duplicate the player and rename the new object to box. Next, remove the player script from the duplicated object, as the box doesn't need it. Move the box to the right of the player in the scene to position it. After that, we'll create a material to give the box some color. Apply the material to the box game object and choose a color that stands out. Now, let's create a new script called box controller to handle the box's behavior. Attach the box controller script to the box game object, and we're all set. Our box is now ready to go. Just like the player object, we have a collider and rigid body attached to the box object, and the settings are fine. Let's open up the box controller script by double-clicking the script file box controller. Let's clean up the box controller script, since we won't need the start or update functions for the box. Now let's switch to the player controller script. Looking at the code, I noticed that target position doesn't need to be a private field since it's only used in one function. To improve the script, let's move target position closer to where it's used, making the code easier to understand. This line checks if there's no obstacle in the direction the player wants to move. It uses a physics. Raycast to cast an invisible ray from the player's position in the specified direction. The ray checks up to 1 unit away for objects on the blocking layer. If it doesn't hit anything, the player can move. Blocking layer specifies which objects should be treated as obstacles. We'll set this layer in the editor to control what the ray detects. I almost forgot the exclamation mark at the start of the condition. It inverts the result, so this line checks if there's no obstacle within 1 unit in the specified direction. If the path is clear, the code inside the if block will run. In the else if statement, we'll check if the ray hits an object with a tag box. If we hit a box, which we'll tag the box with soon, it means the player is trying to push a box. We can then add the logic for handling the box pushing inside the braces. So we have a blocking layer and a box tag that we need to add in the Unity editor to make sure the code works correctly. Let's do that now. First, select Add Tag and create a new tag called Box. Next, expand the Layers section and type in Blocking Layer. Now select the box object if it's not already selected and assign the box tag to it. Then, under the Layers section, choose Blocking Layer for the box object. We also need to select the blocking layer for the player controller script, but I forgot to save the scripts. Let's save the scripts now and try again. Now it shows up, and we can assign the blocking layer variable in the player controller script with the blocking layer we created earlier. Let's run the game to see if the blocking layer works and prevents us from pushing the box. It looks good, we can move the player, but when we hit the box, the player stops, which is expected. Now let's add the logic to actually push the box. We know for sure now that our blocking layer works. Any object on that layer will prevent the player from moving further. However, if any of those objects have the box tag, they'll be handled in the else if statement. This is where we'll add the logic to move the box if it's hit. We get the box controller component from the collider object that we hit, which contains the logic for the box. If the box has the box controller and the try to push box method returns true, we proceed to move the player. The try to push box method uses almost the same logic as the player's movement. It attempts to move the box in the specified direction, but only if it's not blocked. The method returns true if the box can be moved, and false if it can't be moved, for example, if there's another obstacle in the way. As I mentioned earlier, the player and box movements are very similar. So we can copy the movement logic from the player controller script and paste it into the box controller script. This way, the box will follow the same movement rules, and we can push it around a grid just like the player after we make a few minor changes to adapt it for the box. First, add the blocking layer variable in the box controller script, just like we did in the player controller script. Next, remove the else if statement since we only want to allow one box to be moved at a time. We won't let a box push another box, so we don't need that check here. Then, change the name of the method to try to push box and update its return type to bool. This will return true if the box can be moved, or false if it can't be moved, based on whether the path is blocked. Let's also pass in the move speed as a parameter to the try to push box method. This will allow us to use the same movement speed as the player if we want to tweak it later. We'll also create a private variable called isMoving to keep track of whether the box is currently moving. This will help us prevent pushing the box while it's already in motion, just like the player script. Lastly, let's make the try to push box method public, so it can be accessed from the player controller script. I think that's all. Save the scripts and let's test and see if everything works as expected. One more thing before we test the game, we need to set the blocking layer for the box controller as well. This ensures that the box will properly interact with obstacles in the game, just like the player. Select the box and set the blocking layer, just like we did for the player script. Looks nice. It works as expected. The player can move around, and we can push the box. Now, we also need to test that we can only push one box at a time, ensuring that the player can't push multiple boxes simultaneously. But before we add more boxes, let's test the move speed since we haven't tried that yet. Select the player object in the hierarchy. Change the move speed in the inspector to a positive number of your choice and test the game. Looks fine. I think around 5 is a good speed for this game. Now that we've tested the movement speed, we can move forward and add more boxes. Drag the box object from the hierarchy to the prefab folder. This will create a prefab of the box, so we can easily create more boxes, reuse them, or instantiate them in the game later. Select the newly created prefab and drag it back into the hierarchy window to create more boxes. You can then change the position of each box in the scene to set them up as you like. When you've placed your boxes in the scene, we can test the game again to verify that we can only push one box at a time, just like in any Sokoban game. Awesome. Everything works as expected. In this episode, we added the box object to the scene and set up its movement mechanics and implemented logic to allow the player to push the boxes, while ensuring only one box can be pushed at a time. We also created a prefab of the box, allowing us to easily add more boxes to the scene. That's it for today's episode. Thanks for following along, and I hope you enjoyed it and learned something new. In the next episode, we will be adding walls and goals so we know where the player can move and where to push the boxes. Stay tuned for that as we continue building the Sokoban game. Thank you for watching, and don't forget to like and subscribe so you won't miss the upcoming episodes. See you in the next one.